For number 10, I think the easiest way is to think about these functions, their parent functions, and then the transformations of the functions. So I've written the parent function equations on the first line, and then the transformations that they give you below it. And it's kind of like when you first learn to read, like cat. You sound it out, cat, and then you just eventually just read the word, and then eventually you read the word and you just envision the cat, and then your cat is probably sitting on your homework while you're trying to study, and any number of other things. So when you look at these kind of functions, you want to envision their parent function to start. An absolute value function is just the face-up V shape. And then I want to take that absolute value and subtract 2 units from it. So it's going to bring the whole function down 2 units, or graph down. Okay, and then I'm going to do the same idea with the squared, which is going to generate a parabola face-up curve. Then I want to take that curve and drop it 2 units. And then again, well, this is the same one. Don't really need to redraw it, but here we go. And then now that the -2 is on the inside of the squaring, I'm actually affecting it in a horizontal fashion. And even though it's a -2, it's actually the opposite of that because you're looking for an x value that makes it 0 inside of here. So it's a +2 that would make it 0. So I want to go to the right 2 units. And then the face-up curve. Not very well drawn, but serves our purposes. And an x cubed is a snaking kind of graph, something like that. Which the -2 is on the outside of the cubing, so it's going to drop 2 units. And so the snake is going to turn at -2. All right, so now answering the question, we want to know for what the y value is always greater than or equal to -1. And so that's going to be C over here, because here's a y value of -1. So here's the line y equals -1. And the graph is always above that. So that's what we're looking for.